Hi, my name is Pamela Britton, and I'm a PhD candidate at the Ontario Institute for Studies in Education at the University of Toronto. I'm here today representing the Canadian Journal of Science, Mathematics, and Technology Education. The CJSMTE is one of the leading international journals in the fields of science, mathematics, and technology education, and strives to offer high-quality, peer-reviewed articles covering a variety of topics in the STEM education fields. Here with me today to talk about one such article is Dr. Yan. Her article, co-authored with Dr. Marmer and Dr. Zaskis, is titled Calculus for Teachers, Perspectives and Considerations of Mathematicians. Welcome, Dr. Yan, and thank you for joining me today.
Thank you for having me.
Why don't we start by telling us a little about the article? What's it about?
Okay, so my co-authors and I are interested in two questions. One is, what does a calculus course for teachers look like? And the other is, what particular features do mathematicians consider important in such a course? So to answer these questions, we interviewed 24 mathematicians from 10 research-intensive universities across Canada. And what we found was that, first, mathematicians deeply appreciated the human aspect of calculus, and therefore they emphasize the human aspect of mathematical development and activity. So that means there is lots of room for mathematical investigation, for example, for teachers. Second, the mathematicians did not suggest a simplified version of calculus course for the teacher population, but rather they suggested a similar course offered to mathematics majors. So this means that understanding proofs, doing some proofs, and getting a sense of mathematical rigor is a good thing for teachers.
Excellent. And where did your inspiration for the article come from? Why this kind of focus on mathematicians specifically, and then looking at calculus in education?
Mm-hmm. So the inspiration or the ideas for this paper come from our experience of working with secondary math teachers and our observation of how calculus courses are currently structured in universities. So in most universities, calculus is one of the standard mathematics courses offered to a wide range of student populations. And for this reason, there isn't just one calculus course, but special calculus courses for business, life sciences, engineering, and some social sciences majors. Despite the fact that prospective secondary math teachers are often required to take one or two calculus courses in university, a special calculus course designed for teachers is rarely available. And research has shown that learning calculus at the undergraduate level would promote prospective teachers' understanding of mathematical concepts introduced in school. So we couldn't help but wonder, would a calculus course for teachers be beneficial, and what such a course would look like?
And what were some of your findings from this study? How did the mathematicians kind of react to all of this, and what ideas did they have?
So I would say there are two main ideas in our paper. One is to the question of what's the use of academic or advanced mathematics for teachers? So there are two levels of subject matter knowledge that appear to be critical for teaching. One level is knowledge of specific topics, concepts, and procedures. And the other level is epistemological knowledge. It's about what mathematics is, what doing mathematics entails, and how mathematics is done, and how it can be done efficiently. So academic or advanced mathematics, such as a calculus course, may not help teachers directly with their classroom teaching, but what they would help is to strengthen their subject meta knowledge at the epistemological level. So that's one idea. The other idea is to the question of what's the purpose of a calculus course for teachers? So the purpose would be, one is to communicate the nature of mathematics. For example, what's the merit, utility, and value of mathematics? So in one of the mathematicians' words, is to excite teachers into learning and be excited about thinking like a mathematician. So this is the content piece. The purpose of calculus course for teachers is also to provide teachers with opportunities for mathematical investigation. So in one of the mathematicians' words, we want to give teachers experience that they would like to take to the classroom. And this is the pedagogical piece. So this distinguishes a calculus course for teachers from other courses.
Excellent. And what made you choose to publish this specifically in the Canadian Journal of Science, Math, and Technology Education? How does it kind of fit in?
Well, so CJSMTE is one of the leading international journals that produces high quality papers. I myself was inspired by many ideas and insights from the CJSMTE authors. It's an honor to have a contribution to the journal. I chose CJSMTE also because in the past, I had a good experience with the editors and the reviewers of the journal. Their feedback was thoughtful and specific, helped me tremendously to reshape my paper.
Wonderful. And if there's anything else you'd like those watching to know or take away from your article, kind of a big hard-hitting point that really stood out?
Yes, I think I'd like my readers to know this paper offers rich connections between mathematics taught in school and the fundamental calculus concepts. So for example, connection between repeating decimals and geometric series. This was suggested by a number of mathematicians. Connection between golden ratio, Fibonacci numbers, Fairy fractions. So when connecting all three, the benefits for teachers are threefold. One is a better understanding of fractions and their location or address on the number line. Two is the importance of the notion of approximation. And three is a deeper understanding of the density of real numbers. Between any two real number, there is always a rational. And connection between pi and power series. What is pi? Teachers know what is defined and how it's defined. The question is, can pi be defined differently? Taking a calculus course would allow teachers to make connection between pi and power series. And take one step further, we could in fact define pi by power series. So yes, I'd like teachers and math educators to know these beautiful connections.
Very nice. Very cross-curricular within mathematics. That's between the different strands in the units. That's wonderful.
Thank you.
Well, thank you very much, Dr. Yan, for taking the time to speak today. If you'd like to learn more or read Dr. Yan's article, please visit the journal online at springer.com/42330. You can also follow us on Twitter at CJSMTE. I'm Pamela Britton, and from everyone here at the Canadian Journal of Science, Mathematics, and Technology Education, thank you so much for joining us today.
Thank you.